So now that we know how to derive or we have the general form of how to derive a Taylor series, we want to start looking for the Taylor series of some common functions. So one in particular that's really helpful in stats in particular is that of e to the x. Okay. There's variations of e to the x that pop up that are very hard to work with. In particular, in the normal distribution, you have e to the negative x squared. And when you want to find the probability of a random variable that's normally distributed, you end up having to integrate this, which is not something that's easy to do. So we can instead use the series representation of it in order to get an approximation. We can essentially, just like we did with the power series before, the Taylor series for e to the x, we can sub in the negative x squared, and then we can just use a few terms of that, however many terms we want, integrate those terms instead. So we'll kind of go through that process in, I think, the next video. For now, we just want to look at what are the Taylor series of some of these common functions. So e to the x is a fairly simple one to start with. So let's remember the general form first. Okay, so we have the nth derivative. We're just going to look at the Maclaurin series. Okay. And again, if you want to center it at a different point, then you can center it at a different point. Okay. But we're just going to look at this form right here. So this is the general form. So essentially all we need to do is find what these derivatives look like. Okay. And for e to the x, that's not too bad, right? Because for e to the x, the derivative is always the same. So f, by the way, the 0th derivative we would just say is the original function. So f of 0 is equal to e to the 0, which is equal to 1. Okay. F prime of 0 is also equal to e to the 0, which is also equal to 1. Okay, so there's really, nothing to do there. And this is just going to be true for all of them because that's what e to the 0 always is. So with this one, there's really not too much to work to do here. Okay, so this derivative part, this is always 1. So that means that e to the x is equal to the sum from n equals 0 to infinity of x to the n over n factorial. Okay, so probably the easiest one that we have. And then if you wanted to look at variations of this, like if we wanted to look at e to the negative x squared, for example, then all we have to do is plug that in for x. Okay, and then simplify it. So this is going to be negative 1 to the n, x to the 2n over n factorial. Okay. Then you do still need to consider where exactly this will converge. This one in particular we already did in an earlier video, right? This will converge for x in negative infinity to infinity. Okay, so that's the interval of convergence. So no need to do this one again. But in general, you do need to consider that as well.